Welcome to Elko New Market Area Private Domestic Wells 101. In talking with well owners and well contractors over the past year and a half, the city staff got the impression that while there are certainly well owners that know a lot about their systems, there are some that know very little. Maybe they just moved into the house and haven't had a well before, or just never had an opportunity to learn about it. So we decided to put this together for those that are interested in knowing more about their well. This is focused on bedrock wells, which is a specific type of well. It's the most common type of well in the Elko New Market area. These wells get their water from the Prairie du Chien aquifer, which is the same aquifer system that the city gets its water from. This slide just shows a map of the Jordan aquifer, of which the Prairie du Chien is a component. It's one of the layers in the Jordan aquifer. In the Elko New Market area, way up here at the north end of it, the Prairie du Chien is the top layer in that aquifer. Underneath the Prairie du Chien is Jordan sandstone. You'll see that on other slides. You can see that, like I said, we're up on the north end, but the aquifer is vast, covers most of southeast Minnesota, down into Iowa, over into Wisconsin and Michigan. And this is mostly a confined aquifer, and that is certainly true in the Elko New Market area. And I will talk a little bit more about what that means in a later slide. You can see on this map, Elko New Market is the red dot down here. Scott County, Carver County, Dakota County. You can see blue indicating the Minnesota, Mississippi, Cannon rivers. And what this map shows is that the water in the aquifer is not just sitting still like a big pool. It's actually moving more like an underground river. It does move pretty slowly, but it moves towards the rivers. So we're on a kind of a high spot, at least in our area geographically. So water in the aquifer in our area is flowing in from the south, which isn't shown, but then continues on to the north towards the Minnesota, northeast towards the Minnesota, Mississippi, and even southeast down toward the Cannon rivers. Let's talk about typical wells in Elko New Market. You're looking at a cross section of the landscape. You can see the ground surface on this line. You can see a house. You can see the well. Down below is an aquifer. This is drawn to scale based on an actual well log in the area, and showing the Prairie du Chien, which is fractured limestone at the top of the Jordan aquifer layer, and then below that the Jordan sandstone layer. They're interconnected, so water moves between them. The house is a typical two-story house, about 20 feet high. So there's roughly 8 or 10 homes worth of thickness on top of that. So give you an idea that aquifers down there and wells here are typically pretty deep. 200-300 feet is not uncommon. The well is basically a long skinny hole down through a layer of silt and clay that is non-water bearing, straight down into the top of the aquifer, usually 4, 5, 10 feet. Into the aquifer, they drill a hole, they put a metal casing 4 or 5 inches in diameter down through that hole to prevent it from collapsing closed. Once they get down into the aquifer itself, they don't need a casing, and I'll show that more on another slide. I mentioned that this aquifer is confined. It's confined by this layer of silt and clay overburden. If you don't drill all the way down to the aquifer and just drill into the silt and clay, you won't get water, or it would be very, very little. It wouldn't be enough to sustain a home. So you have to get to the aquifer to get to the water. But because that clay layer is there and there's parts of the aquifer that are at higher elevations than they are in this area, water's trying to rise to its level, meaning there's pressure in the aquifer. So when you drill that well through the confining layer into the aquifer in an open hole, water will rise up in the well to this aquifer water pressure level. I chose that name just for to make it more intuitive. You may, in talking to a well driller or neighbors, hear about static water level. It's the same thing. It's where the water level actually wants to be, but can't be because of this silt and clay. Anything more on this? Just a little bit about how the well works overall. You have in your home, there's a pressure tank. Typically they're blue, typically in your basement. Most people are familiar with that. There's a set point in there when the pressure in the tank gets low enough, a controller sends electricity down to the pump, which turns on, pumps that pressure tank back up to another set point where it turns off. Because there's air in the tank, it keeps constant or mostly constant pressure on the water in your plumbing. So when you open a tap, even if the pump's not on, you'll get water. And that just cycles. When the pressure gets low enough, turns pump on, fills it back up, and so forth. Go to the next slide. This is a blow up from the last slide showing the static water level at the top. The well, again, you can see maybe a little more detail. I recognize it's small. They'll drill a 6-inch borehole down through the clay. As they get down closer, they can drop to a little bit smaller borehole. They push the 4-inch casing all the way down through, but like I mentioned, down into the aquifer, it can be an open hole. There's no casing required because that rock won't collapse and fill the hole. And water can flow more freely towards the bottom of your casing and up into the static level. The pump needs to be below the static level, but it does not need to be down at the bottom of the aquifer or into the aquifer because water naturally rises up. That static level has been pretty constant for millennia. It varies a little bit depending on climate and usage and so forth, but for the most part, it stays about where it's always been, and so your pump can be comfortably set 20, 30 feet below it and have plenty of water to supply your home. The pump, sit down here, it's hanging in the well from a drop pipe. The drop pipe is typically a 1-inch galvanized pipe with threaded sections, so they're, depending on the supplier, 18 or 20 foot sections or 21 foot sections. They're screwed together enough to get the well down, the pump down below the water level. There's a electrical cable that accompanies that drop pipe, connects to the pump, and that all goes back to the control house or control panel up either in your basement or near the well. And when it gets a signal to turn on, it does that, fills that pressure tank in your home. When the pressure tank is full, it shuts off again. If you open an outdoor spigot or something where the air tank can't keep up, the pump will turn on and keep supplying that water. So the pump I mentioned is typically set something like 20 or 30 feet below that static water level so that any variation won't affect its ability to reach water. We're going to talk a little bit about the types of problems that can happen with wells. A well is a man-made piece of infrastructure, and like anything man-made, eventually requires maintenance. So the kind of things that can happen in a well are shown in the next couple slides. Here we have a cross section. That's a piece of actual drop pipe from a well in this area that was kept after it was replaced by the Public Works Department. They cut it in half. They took a chunk of it, cut it in half longitudinally, and this white and black material inside is what was found there. That is hardness and iron and manganese oxidized that sticks to the inside of that drop pipe and builds up over time. And over enough time, the inside diameter of that drop pipe will get so small that it makes the pump hard pump unable to supply adequate water to the house. The picture on the right is a filter that shows material that's accumulated on it and clogged it up. That material is from the inside of the well casing. There's buildup that happens, oxidized iron and manganese, and that typically just sloughs off a little bit, kind of all the time, collects on your filter starts to slow down, you replace the filter and start the cycle all over again. I won't go through this in great detail. If people are interested, they can certainly look up pump curves and pumps. But this curved line would be how a pump performs versus in gallons per minute on the bottom versus how hard it has to work on the left side. How hard it has to work is a function of how high it has to push the water from its position down in the well up into the home, plus how much friction is happening through the pipes. So a long skinny pipe is going to have more friction than a short fat one. If you've ever drinking a shake through a straw, you probably instantly grasp what I'm talking about. You'll want the short fat one every time if you want a good sip of that shake. So the red lines show what happens if you've got, say, 800 feet, which is just another way of expressing pressure to work against. You draw that red line over to the curve and then go down, and that tells me, okay, this particular pump on that curve at 800 feet of head will pump 7 gallons a minute. If that drop pipe and piping to your home gets smaller because of buildup, this moves over, and say we're at almost 900 feet of pressure, the performance drops down to 5 GPM. And there gets to be a point where it has to work so hard that the pump will simply shut off. It can't push water anymore. And so that's one of the problems that happens, is that buildup happens in drop pipes over time. The other place that you can have trouble is inside the well casing. I showed that picture of the clogged filter. That's material from inside the casing, outside the drop pipe, that builds up over time inside the casing and comes off and gets pumped into the house. So you've got to filter it out, or it ends up in your softener or even at your tap. This stuff can build up so much that it can freeze a pump to the casing. So a good reason to have your pump pulled out and checked periodically so that it doesn't get locked in. There are well contractors that will tell you they've had to pound on the casing, or on the casing, on the drop pipe with a hammer to try and bust it loose. Sometimes they can't. If they can't get that pump out, your well is done for. So that is an important reason to have these periodically checked. The other thing that can happen is in the drop pipe, corrosion, because it's a metal pipe in a moist environment, will corrode over time. That pipe is galvanized, which offers protection pretty well for a long time, but it eventually does corrode. You can get pinholes in that drop pipe, and so when the pump is on, it's going to spray water out of those pinholes against the walls of the casing and wash that built up material down to where your pump can grab it, and you'll get dirty water. So as far as the pinholes, you just imagine that corrosion happened and there's holes through this drop pipe. This area is under pressure when the pump is on, and even when it's not, although there are check valves that reduce that to keep water from flowing back into your well. But when the pump is on, it's pushing as hard out those pinholes as it is up the pipe, and water will spray out and hit the walls of the well casing. So we've learned quite a bit from well contractors about maintenance and what to do, and thought I'd share some of that in the next few slides. Number one, know your well. Where is it? Is it accessible? If someone needs to get at it, is there a tree in the way, or a deck, or a doghouse, um, or a garden? You want them to be able to back a truck up to it, because they use sort of a crane device to hook up that drop pipe and pull the pump out. How it works, which hopefully we've given you a little bit of information on in previous slides, and how it sounds. Um, if you're in the room where your air tank is, uh, you probably can hear something happening, click, and maybe some hissing or buzzing sounds or something when the pump is trying to fill that air tank. And if that sounds different, or doesn't sound at all, or sounds too long, that can be a sign there's something going on with your drop pipe. So that leads to paying attention. Some signs that you've got problems with your drop pipe or well would be higher electrical bills. If the pump has to run significantly longer to fill your air tank because of pinholes, or the pump is running longer than usual, or the pump is running even if you're not using water, that can be a sign there's pinholes. Dirty water that you can't address by flushing very well, that can be caused by pinholes and signs of problems with your drop pipe. One thing you could do, if you can hear when the pump is running, time a few pump cycles once or twice a year. Write it down and compare how it's changing from time to time. If it's normally 3 minutes, and then 1 year you measure it at 6 minutes, that could be a sign there's something going on, either buildup inside the drop pipe, or pinholes, or corrosion. Although it's kind of a common sense thing, it's easy to put off taking proactive measures with your well. As long as it's working, most folks don't think about it, and that's perfectly normal. But it is a good idea to know who your well contractor is going to be. You might talk to some ahead of time, choose one that you want to work with, have their number handy, but be proactive. If you are aware that it's been a long time since you've had your pump pulled, or you're seeing some dirty water or signs, try and get that taken care of during normal business times. The last thing you want to do is run out of water on Christmas Day, not know who to call, and spend your whole day trying to track down a well contractor that's willing to come out on Christmas. That can be pretty well avoided by being proactive. Update your treatment equipment as needed to improve the water quality of your taps. If you're not satisfied with it, talk to your well contractor or a treatment system vendor, see what they recommend. We know the water in this area is high in rust, high in oxidized manganese, high in hardness. So typically you'll have a iron filter at the front of your treatment works and a softening system, and I think most people already do, but make sure that stuff's all good and working, and that'll help get better water at the tap. Another thing you can do is periodically flush your well, and that's pretty simple to do. You turn on taps outside your house. Those taps are typically not getting water through your softener, through your treatment system, so it's taking water pretty much directly from the well, and the more you open, the easier it is for that pump to work, and it'll push water faster through your drop pipe and do a better job of flushing stuff out. Anything that's loose in there that might otherwise come out and end up in your bathtub, you can flush out once or twice a year and adjust it based on what you see. You open those taps, you watch the water. If it's dark, you let it run until it's clear, and that should help quite a bit in maintaining less impact on your treatment system. One thing the city wants folks to know is that there are some wells out in the area that are deep enough, but over time, as the city grows and as perhaps other township use grows, there can be drawdown that will eventually affect these wells. We have a pretty good idea with the DNR where some of these are. They're good for now, but if you are going to have your pump pulled, to have it inspected or your drop pipe repaired or your pump replaced, call City Hall, leave some contact information and the name of your contractor. We will call them and look at the records and see if your well is one that would benefit, because maybe it's good enough, but over time it's worth a little bit of money to put it deeper. The city will pay to drop that pump deeper into the well by paying for the extra drop pipe and wiring, if yours is a good candidate for that. Most won't need that, but we would appreciate the opportunity to check that. It's the easiest time to do it for everybody, for you, for the city, and for the well contractor. Otherwise, if you have an outage sometime in the future, that'll be a special trip. You'll be out of water. So if we can avoid that by communicating, we think that's worth doing. So since you're watching this online, most likely, I'm obviously not available to answer questions right now, but the city will be hosting an open house meeting. You'll be notified of that if you haven't been already. And if you do have questions after this presentation, feel free to show up at the meeting and ask us in person. Thank you.